Hi, welcome to Dissolved Chemistry. Let us continue our discussion on this ionic equilibrium. In the previous video, we have discussed regarding hydrolysis of salt and their pH. Okay, so in the present video, we will discuss regarding common ion effect and buffer solution, which are very important topic. So let us start with common ion effect. So we will go in detail with this. So common ion effect means, suppose if you take a weak acid solution in water, okay, weak acid solution in water, okay, we will take, say for example, acetic acid in water. So then what happens, you will be getting, partially it will ionize, partially means only few of acetic acid molecule will dissociate in water to give what, acetate ion and H3O plus ion in water. Okay. Now, what happens to such solution if you add any of the solution which contains either AH plus or CS3COO minus? Means one of the ion common in this solution. If you add from outside, then what happens? The ionization of the weak acid is being suppressed, and that suppression we call it as what? Due to addition of either ion, okay, into the solution is called as what? Common ion effect. Okay, the suppression of, we will write like this, the suppression of dissociation of weak acid or weak base in aqueous medium due to addition of the solution containing common ion is called common ion effect, and this is going to happen according to Everly-Chatelier principle. Okay, so if I increase the concentration of H plus ions, if I add the solution containing H plus ions, then immediately what happens? The equilibrium will shift back to form undissociated acetic acid. Meaning is what? So already whatever the acetate ions are present in the solution, that are also being what? Converted into undissociated acetic form due to increase in the concentration of H plus ion of the solution. Okay, so therefore that we will give HA. Okay, so its dissociation we will give as weak acid, you consider, plus A minus. So the dissociation constant of this acid we will give as Ka is equal to concentration of AH plus ion and A minus ion divided by HA, that is undissociated form of the acid. Okay, so now, so if you want to check the H plus ion concentration of the solution, then what you will be getting? Ka into HA divided by A minus. Now suppose if you are adding the solution, okay, any salt solution to that, right? So then what happens? You will be having acetate ion concentration is only because from the salt, because salt will be what? Completely dissociated form. And whatever the salt which is being generated from acid, already it combines with what? Common ion and forms back a what? Undissociated form. So therefore, the H plus ion concentration we will give Ka into concentration of the acid in the given solution divided by concentration of the salt which is being added additionally. Okay, so this is how we can give the hydrogen ion concentration of the solution of weak acid which is being added with the salt solution. Okay, so this is all about common ion effect, and now we will talk about a very important topic, that is buffer solution. Right, prior to understand the meaning of this buffer, so we come across these buffer solutions in various biological system. Your blood itself is going to act as a buffer solution. Okay, so what this buffer means? These buffer solutions are defined as the solution which resist the change in pH. Resist the change in pH of the solution upon addition of small amount of acid or base. Okay, so let us try to understand this one with an example. Okay, so what do you mean by the resistance to the change in the pH? So we know that simple, if you take water, we know that its pH will be 7. Okay, water we have taken, its pH will be 7. Now suppose only 1 ml of H plus, that is HCl, strong acid, if I add to this, then what happens? So your pH will go down, or it will be less than 7. Okay, so now what you do is you take a solution of sodium acetate and acetic acid. It's a weak acid and its salt with a strong base. So it is a salt of what? Weak acid and strong base and weak acid. If you take the mixture of these two, then what happens? And if you add the acid to this, then we will see that one. Okay. So this acetic acid will act as a reserve of H plus ions, and your CS3COO Na will act as a reserve of CS3COO minus ions. Okay. So in presence of this salt, the acetic acid will remain undissociated form. Already we have discussed in common ion effect. Okay, so therefore your solution will be having acetate ions and acetic acid molecules in water. Now to such solution, if you add HCl, say for example, as soon as HCl comes in contact with this, then immediately the H plus ion from this HCl is taken by the acetate ion to form undissociated acetic acid. So therefore, to certain extent, if you add the HCl, it will not allow the increase in the concentration of the H plus ion. Similarly, suppose if you add base NaOH, then as the OH minus ion comes in the water, immediately that what happens, the H plus from the acetic acid means acetic acid will dissociate, okay, and forms acetate ion, and it will neutralize the OH minus ion. So therefore, what it is doing, either you add acid, either you add base. So what it is doing, it is resisting the change in the pH of the solution, and such solutions we call it as what? Buffer solutions. There are 3 different types of buffer solutions we have, and all those 3 types we will see. Okay. One we call it as what? Acidic buffer. Okay, second one is called neutral buffer we will take. And third one we call it as what? Basic buffer. Okay, So acidic buffer will be always, it is a mixture of weak acid and salt of weak acid, strong base. Okay. Example, already we have discussed this in detail, plus CH3COONA. Similarly, neutral buffer will be aqueous solution of salt of weak acid, weak base. So just if you add this salt, it is enough. Okay, no need to take any acid or base, only if you take the salt, that is enough. Okay, so ammonium acetate will act as what? Neutral buffer. Now the basic buffer will be what? Aqueous solution of salt of weak acid, weak base. Example is ammonium chloride and ammonium hydroxide. Here ammonium hydroxide is weak base and ammonium chloride is its salt. Okay. So already as we have discussed regarding this, okay, as an example, now we will see this how it is going to, and here the pH we can maintain 4.75. Okay, we can maintain the pH constant as 4.75 using this mixture. Okay, so then here we can maintain the pH 9.25. Okay, and here we can maintain the pH 7. Okay, so how this neutral buffer will act, we will see that one. So now it is a strong electrolyte, ammonium acetate. If you dissolve in water, you will be having acetate ions and ammonium cation. Already in the common ion effect or hydrolysis, okay, of salts, we have seen that it will remain neutral. Okay, so now to this, if you add, say for example HCl, then what happens? As the H plus ion comes, immediately it combines with acetate ion to form acetic acid. And suppose if you add NaOH base, okay, it will immediately, OH minus ion will combine with what? Ammonium cation to form ammonium hydroxide or ammonia plus water. So this is how what happens. It will tolerate the increase in the hydrogen ion concentration as well as OH minus ion concentration. Similarly, we will see last one, that is, so suppose, so it will be having ammonium cations and ammonia. So if you add the acid, then what happens? This ammonia will take up that proton and it will form ammonium cation, right? And ammonium cation, when you add the base, okay, so immediately it will give the proton and forms ammonia plus what? H2O. So that is how it is going to tolerate the alteration in the pH, or it will not allow the change in the pH upon addition of small acid or small amount of the bases to the solution, and this we call it as what? Buffer solutions. Okay, then how to check the pH of the solution, so that we will see. Okay, so already we know that, so the hydrogen ion concentration of such solutions will be given by this equation, Ka is into what? So that is acid by salt. Okay, so already we have seen this one. And now if you apply log on both sides, negative log on both sides, so minus log of H plus is equal to minus log of Ka into acid by base. So therefore, A into B, log A into B will be what? Log A minus log B. We will write log Ka plus log what it turns out to be. To change the sign, negative log we have multiplied. So therefore, what you will be getting, salt will go up and then you will be getting acid. Negative log of H plus ion is nothing but what? pH is equal to pKa, okay, plus log salt by acid. So this is all about buffer solution and how to calculate the pH of the buffer solution. Okay, I hope you have understood the meaning of what is common ion effect and what is buffer solution. Okay, thank you for watching.